Okay, so we did this problem with p-value, change it up, and do it with a critical value. Okay, I don't need to erase my conclusion because I'll make the same conclusion. Should make the same conclusion. If I make a different conclusion, I made a mistake, right? So let's do this with critical value. All right. So you start with the you always assume HO is true. Okay, and then you talk about the distribution of your test statistic, right, which is centered on 0, if the null is true. Okay, so let's see. In a right-sided test, that's one we did before, we put all of alpha on the right side, and we called that rejection region there. But since it's a two-tail test, we'll have rejection regions on both tails. Yeah? So alpha can't be all on one side. Right? Alpha, in this case, is 0.05. I got to split it up between the two sides. So how much is both sides going to have?
2.5.
0.025, right? Or 2.5%.
2.5. Yeah.
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 So 0.025, right? What am I doing? I'm doing 0.05 and I'm dividing it in half to put it in both tails. Because alpha is 0.05. So I'm putting it in both tails. Okay. So there we go. I have 0.025 in the tail. Now the negative one is always easier to look up, right? Because this area in the behind is already clearly explained that that's 0.025. The positive one, I would have to add whatever this area and that area. So anyway, they'll both be the same because it's a symmetric distribution, right? So whatever this number is should be the same as this number, just that one's negative. So I go in my table and I look for where the area is 0.025. Okay, so 0.025. It's there. It's exactly there. Okay, so pull out your table and make sure you can find it. 0.025. What does that correspond to? Negative 1.96. Negative 1.96. Okay, so this one will be positive 1.96. What is the area in between these two, actually?
95.
0.95, right? Because if you add up 0.025, 0.025, 0.95, you should get 1, right? So actually, if you were to look up, if I wanted to figure out this without just assuming that they're the same, how would I look it up? What would be the area behind this number?
If you looked up 1.96 in the Z table, the area is
1.9, or sorry.
No, if you look that area up,
What is that area? 0.9.
0.95 plus the 0.025.
0.975. Yeah. 0.975. So if you go inside your table on the positive side and you look up 0.975, okay, you also get 1.96. So that's just double check. That's just a way. But you didn't have to do that. But because of symmetry, that was the same number.
Mm-hmm.
Makes sense? Okay, so these areas are my, these areas here are my rejection, right? So these are my rejection regions. Alright, so my observed test statistic is negative it's negative 0.86, right? Which is not quite to negative 1.96, right? So it's not in the rejection region. So you failed to reject. And you have the same conclusion that there's not enough evidence. It's just that the mean dive is different than 1312. Okay, so in the next video, we're going to talk about, in these two videos we talked about sigma known. Let us switch talking one more example where sigma is unknown.